Hi, good morning my dear students. Today we are going to give introduction to a new chapter in physics, namely light, reflection and refraction we are going to study. I hope you must have defined energy in your 9th standard. What is energy? It is the capacity to do work. What are all the different forms of energy? As an example we have mentioned, light is a form of energy, sound is a form of energy, electricity is a form of energy, and chemicals also, they are all forms of energy. So today we are going to study one type of energy which is called as light. So we all must know that light is a form of energy. At the beginning years when light was detected and studied by different scientists, there was a confusion how light is traveling from one point to another. For example, when you go to the terrace of the building in the dark night, we are able to see the stars. The stars are visible to us as dots, point sources. We are able to see the stars means the light is traveling from the star up to our eyes. Every day morning we are able to see the sunrise, and evening we are able to see the sunset. So these are all natural sources of light. The sun and all the stars which we look in our everyday life, they are all self-luminous because they produce their own light and emit their own light. How does this light travel through such a long distance from the sky? Very long distance the light is traveling. Whether it is traveling as a particle or whether it is traveling as a wave, there was a confusion. So there were different theories of light which started with the efforts of Isaac Newton. So as an introduction, I will tell you the various theories of light. The first successful theory of light was given by Isaac Newton, and the name of the theory is corpuscular theory of light. So according to Isaac Newton, light is considered to be made up of a continuous row of particles, and he named these particles as corpuscles. Okay, so according to Isaac Newton, light is made up of particles and they were named as corpuscles. What type of particles are they? Means they are tiny. Okay, they are tiny and massless elastic spheres. These tiny massless elastic spheres with which light is made up of, according to Newton, they are only called as corpuscles. And the light energy is the kinetic energy of these corpuscles. But with this theory, Isaac Newton could prove that rectilinear propagation of light. He proved that light travels in a straight line using corpuscular theory. And also he verified the laws of reflection and refraction. But some other higher level properties like polarization, interference, diffraction and all could not be explained based on this theory. So, next theory, namely the wave theory, came into existence, which was given by Christian Huygens. And Huygens could prove all the properties almost, which Newton proved and disproved also. Everything were proved by Huygens using this wave theory. And initially, he assumed that light travels in the form of longitudinal waves. But it was wrong. It was corrected by Fresnel, Foucault and Michelson and some other scientists. So it was later corrected to be transverse waves. And these transverse waves travel through space. After that came into existence the electromagnetic theory, which was formulated by Maxwell. According to Maxwell, the light travels in the form of waves only, but as Huygens suggested, they are not mechanical waves, but they are electromagnetic waves. And these electromagnetic waves now travel in the form of vibrating electric field and magnetic field. Suppose if this is the electric field vibrations, okay, this is the electric field vibrations, and perpendicular to this are the magnetic field vibrations. So magnetic field vibrations such that perpendicular to both these electric and magnetic field vibrations, the light waves are traveling, okay? Light waves are traveling perpendicular to both electric and magnetic field vibrations. So, this theory was named as electromagnetic theory. And there was a drawback of that theory also. It could not explain photoelectric effect. So, to overcome these difficulties came the final successful theory, namely quantum theory of light. Okay, today we are studying light more based on this theory, namely quantum theory of light, which was formulated by Max Planck first. So, according to Max Planck, light is made up of packets of energy which are called as quanta. The singular is quantum and the plural is quanta. Just like Isaac Newton considered light is made up of discrete packets called corpuscles, this Max Planck considered that light is made up of continuous but discrete packets of energy. Okay, so there is no fractional packet of energy. Each packet of energy was named as quantum and the plural form was named as quanta. Later on, this theory was supported by Albert Einstein also. According to Einstein, this light packets are renamed as photons. Photons, the singular is photon. Okay, so the quantum was only called as what? Photon, and the energy of each photon was given by E is equal to h nu. Okay, so h is called a constant, which is now called as Planck's constant. And nu, the Greek symbol nu, is called the frequency of light energy, and E is the energy in joules. Okay, so these are all the various theories of light, and every theory is successful to some extent, and there were some drawbacks also for every theory. Anyhow, what is the branch of physics which deals with the study of light and its properties and applications? That is called as optics. Okay, so optics is that branch of physics. Optics is that branch of physics which deals with the study of light and its properties. There are two types of optics, namely geometric, geometric optics, and the other one is called as physical optics. Physical optics. The geometrical optics is otherwise called as ray optics. Ray optics. And the physical optics is otherwise called as wave optics. So these are the two branches of optics which deals with the study of light, its properties and applications. Now in the 10th standard you are having more about ray optics. Okay, light is treated to be a ray. So what is meant by a ray of light? So here, ray of light. How do you represent a ray of light? So throughout this chapter you are going to consider light as a straight line having an arrowhead. So this is the diagrammatic representation of a ray of light. Sometimes so many rays of light will travel parallel to each other. A bunch of rays, that is called as a beam. Okay, a beam of light. So what is meant by a beam of light? It is a collection of so many rays. Suppose if the rays are parallel to each other, okay, this is called a parallel beam. Parallel beam. Okay, this is called as what? A parallel beam. Suppose if you take so many rays which are all meeting at a single point. So these are all the different rays of light which are meeting at a point. Then such rays are called converging rays, and such a beam is called as a converging beam. Okay, this is called as a converging beam. Suppose from a point, if different rays are going away from each other, means this is called as a diverging beam. Okay, this beam is called as a diverging beam. So what are the three types of beams we have discussed? Is one is what? Parallel beam. Another one is converging beam, where all the rays of light are meeting at a point, and the third one is a diverging beam, from where from a point all the rays are going away from each other. Okay students, now the introduction is over. We are going to study directly reflection at a plane surface. Be ready for that. Be ready. Now we are going to discuss reflection of light. So for this I have considered a plane surface xy whose top surface is polished and reflecting. The bottom surface is rough surface, which is non-reflecting surface. So xy is a reflecting surface like a mirror or highly polished metal surface placed on a horizontal plane. Now a ray of light which is denoted by AB is incident at the point B. Then at the same point I have drawn a perpendicular to the horizontal surface. The perpendicular drawn to the horizontal reflecting surface is called as the normal. So here BN is the normal to the reflecting surface. It is found that the light after incident on the reflecting surface xy will deviate from its original path. Understand? It will deviate from its original path and it will retrace in the same medium. It will rebound inside the same medium. Okay. So the angle made by the incident ray AB, okay, with the normal is denoted by I, and the angle made by the reflected ray BC with the normal is denoted by R. So in this picture, what is AB? AB is the incident ray and BC is the reflected ray. And what is BN? It is the normal drawn to the reflecting surface. And now you can say that small I is the angle of incidence. So angle of incidence, how to define? Angle of incidence is defined as the angle made by the incident ray with the normal. Okay. Similarly, what is small r denote? Small r is defined as the angle of reflection. Okay. That is the angle made by the reflected ray with the normal at the point of incidence. This is called as what? Angle of reflection. Okay. Suppose you take that if this reflecting surface xy is absent, it is not present. What should have happened to the light ray AB? It should have traveled along the direction ABD without any deviation. But now because of the presence of the reflecting surface xy, it has deviated, is it not? That means what? From this original direction, it has turned through some angle. It has turned through some angle and it is moving inside the first medium itself. Okay? So how much is the angle we want to measure? For that, you see here this angle, the remaining angle, okay? The angle which is 90 minus angle of incidence. This angle is denoted as what? Theta. And this is also equal to what? 90 minus angle of incidence. Understand? This angle I am denoting by the symbol theta. And vertically opposite angle, this also will be equal to what? Theta. And if you measure these two angles I and R, it is found that I is also equal to what? R. So this angle also must be equal to theta. So by how much angle this light ray AB has deviated? It must be equal to theta plus theta is equal to how much? 2 theta. Is it not? Okay. Now what is this angle theta called as? This angle theta, which is the angle between the incident ray and the reflecting surface. The angle made by the incident ray with the normal we have already defined as angle of incidence. But what is the name of the angle made by the incident ray AB with the reflecting surface? That is also having a special name, that is called as a glancing angle. So theta is called as glancing angle. Understand? So this theta plus theta, by this angle 2 theta only, the light has deviated from the path BD towards BC. Therefore, this 2 theta is called as the deviation, angle of deviation. So deviation produced is equal to twice the glancing angle. Twice the glancing angle. Okay, students, have you understood? So what is meant by angle of incidence? It is the angle made by the incident ray with the normal. What is the angle of reflection? It is the angle made by the reflected ray with the normal. And you see that theta is called as what? It is the glancing angle. How do you define? It is the angle made by the incident ray with the reflecting surface. It is found to be 90 minus angle of incidence. Okay, based on this now, we are going to summarize the laws of reflection. Laws. There are some interesting points called as laws of reflection. This is very, very important. There are two laws. The first one is, you see here, the incident ray AB, the reflected ray BC, and the normal at the point of incidence, namely BN, all are lying on the same plane. So, the incident ray, here in this picture, what is the incident ray is AB, okay, and the reflected ray and the normal at the point of incidence, all lie, okay, all lie in the same plane, Here they are all lying on the board. Board is a vertical plane. So all these are lying on the board, okay. And the second one is very, very important, angle of incidence, okay. Angle of incidence is equal to the angle of reflection, okay. Angle of incidence is equal to the angle of reflection, that is angle I is equal to angle R. This is the second law of reflection. Have you all understood? So what are the two laws of reflection we have studied? Now in our everyday life we are using different types of mirrors. So what are the different types of mirrors which we are using in our everyday life is plane mirrors. So plane mirrors are used in the dressing table, okay, and the spherical mirrors such as the concave mirror and the convex mirrors are also being used for various applications. Now first we are going to discuss about a plane mirror. So image formed by a plane mirror, okay, image formed by plane mirror, So in our earlier classes also about a plane mirror you should have studied. Suppose if you stand in front of the dressing table mirror, which is a plane mirror, you are able to see your face, and the size of the image will be the same as that of the object, and the distance of the image inside the mirror is also equal to the distance from the mirror to the object. So these are all our practical experiences I am talking. In our everyday life we are watching. Suppose if you raise your right hand, means which hand the image will raise? Yes, that is the left hand. Okay, why it is lifting the left hand when you are raising the right hand? Then what should be the process or the name of the image? It is called as, yes, it is laterally inverted. And also when you stand upright in front of the mirror, the image also will be upright. Isn't it? When you are erect means then the image also will be what? Erect. Isn't it? It will not be inverted. So I am going to summarize only the points which you have studied in the earlier classes. So what type of image will be formed by a plane mirror means, the first one is, we can say that it is virtual and erect. Okay, virtual and erect image. So once again we are going to summarize at the end the differences between the different types of images. But first, what type of image is being formed we should know. So we will say that virtual and erect. Okay. So virtual means that image cannot be caught on the screen, and erect means it will be the same position as that of the, the same head to toe will be erect. Okay. Then the second one is laterally inverted. So it is laterally inverted. And the third one is image size will be equal to that of the object size. Okay, so image size is equal to object size. Then the image distance is equal to the object distance. So many other properties are there. Okay, at least you must remember at the 10th standard level these three very important points. Okay, so what are the nature of the image formed I have written. Okay. So once again, to summarize this, what we have studied today is the reflection of light. So in simple words, if you say what is meant by reflection of light, means when a ray of light traveling in one medium is incident on some other medium or surface, and if the light deviates from its original path and travels back into the first medium itself, then such a phenomenon only is called as the reflection of light. Okay. And we have discussed some basic definitions like the theories of light, the 4 theories of light. The first successful theory was given by Isaac Newton and it is called as the corpuscular theory. And the second theory was given by Huygens and it is called as the wave theory. The third theory is called as electromagnetic theory of light, which was given by Maxwell. And the fourth theory is the quantum theory of light, which was given by Max Planck and it was extended by Albert Einstein. Okay. Then we have drawn the pictorial representation of a ray of light. Then a collection of rays called a beam of light. There are different types of beams, namely there is a parallel beam, diverging beam, converging beam and all. Okay. Then we have discussed the reflection of light taking place at a plane reflecting surface. And we have defined incident ray, reflected ray, normal, then glancing angle, then angle of deviation. Okay. Then based on this we have formulated the 2 laws of reflection. Okay. So what are the 2 laws of reflection? Once again let us read it together. Come on, what is the first law of reflection? The incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. And what is the second law? Yes, the angle of incidence is equal to the angle of reflection. And finally, we have summarized the nature of the image formed by the plane mirror. So a plane mirror forms a virtual and erect image. Virtual images can never be caught on a screen. Okay. And the second one is what? Laterally inverted. This is why when you lift your right arm, the image will lift its left arm. And the size of the image is equal to what? The size of the object. So the next following topic will be spherical mirrors. Until then.